In this video, we're going to explore the basics of atomic structure. Atoms are composed of three subatomic particles. We have protons, which carry with them a positive charge, and neutrons, which have no charge, they are electrically neutral, are both found in the nucleus of an atom. We also have electrons, which carry with them a negative charge, which can be found in the area outside of the nucleus. Atoms are electrically neutral. This means that the number of protons and electrons will be equal. We'll see that this will change later on when we talk about something called ions. But for now, we're going to just discuss neutral atoms with an equal number of protons and electrons. Since most of the mass of an atom is found in the nucleus, we consider it to be the atomic mass the sum of the protons plus the neutrons. Atoms are incredibly tiny little things. 1 teaspoon of water will have nearly 3 times as many atoms in it as the Atlantic Ocean has teaspoons of water total. Most of the atom, however, is empty space. Again, we find our protons and our neutrons here in the nucleus, but then in a very vast region outside that, we find the electrons. One analogy to think of is that if we picture something like the Houston Astrodome as the volume of an entire atom, the nucleus can be pictured as one golf ball hanging in the very center of the entire dome. That is where all of the protons and neutrons and pretty much all of the mass of the atom can be found. The rest of the dome is where the electrons would be buzzing around, which we can picture as mosquitoes buzzing around the entire dome. Atoms are identified by something we call the atomic number. The atomic number is equal to the number of protons in the nucleus of that type of atom. For instance, the atomic number of aluminum is 13. This means that an aluminum atom has 13 protons in its nucleus. It's important to recognize that this is the absolute identifier of an atom. Every single aluminum atom in the universe has 13 protons. That's what makes it aluminum. That is what gives aluminum its identity. The atomic number can be found very easily in every box of each element in the periodic table. The mass number is equal to the total number of particles in the nucleus of an atom. In other words, it's equal to the number of protons plus the number of neutrons. When writing down an element, it's important for us to note what the mass number is, and so we quite often use this notation, in which X will be the symbol of the element. Let's look at an example using carbon with the symbol C. A is equal to the mass number and written to the left as a superscript. In this example, we're talking about a carbon atom that has 6 protons and 6 neutrons, so the mass number is 12. We look on the periodic table and we see the atomic number for carbon is 6, and so that gets written as a subscript also to the left of the element. Quite often, you won't find Z written with this notation. You won't find the atomic number. The reason for that is as long as we have the elemental symbol, we can always look on the periodic table and see what the atomic number is. As mentioned in the last slide, a carbon atom with 6 protons and 6 neutrons would have a mass number of 12. Likewise, carbon with a mass number of 13 would have 6 protons. Again, that's what makes it carbon, is having 6 protons. And so carbon 13 would then have to have 7 neutrons, and so forth. Elements that have different numbers of neutrons are called isotopes of that element. And so, for example, when we look at some of the different types of carbon, carbon-12 has those 6 protons and 6 neutrons. Carbon-13 still has 6 protons, but 7 neutrons. We also have carbon-14, which has 6 protons and 8 neutrons. All 3 of these are different isotopes of carbon. They all have 6 protons, that's what makes them carbon, but they have different numbers of neutrons. Let's look at some other examples. Fluorine has the symbol F found on the periodic table. We also see on the periodic table that the atomic number of fluorine is 9, meaning there are 9 protons in the nucleus. If there are 9 protons in the nucleus, that means there have to be 9 electrons in a neutral fluorine atom. If we're talking about fluorine with a mass number of 19, that means that 19 is equal to our number of protons plus our number of neutrons. And so that means that there has to be 10 neutrons in a fluorine 19 atom. And we would write that like this. Again, here's our symbol for the element, F. We write our mass number as a superscript to the left, and our atomic number as a subscript to the left. And thus, fluorine 19 contains 9 protons and 10 neutrons. The existence of isotopes means that all atoms of an element are not exactly the same. All atoms of the same element will have the same number of protons in the nucleus. However, atoms of the same element can have different numbers of neutrons. As we saw before, we write different isotopes using this notation. X will stand for simply whatever the symbol for that element is. A will be the mass number for that particular isotope, the number of protons plus the number of neutrons, and Z is the atomic number for that element. Another way that we sometimes write out an element is if we actually write out the name of the element, followed by a dash, and then the mass number. So in this case, we have the isotope oxygen-16. If we're then writing that in our isotope notation, then we're going to write the symbol for our element is O. We said that this is oxygen-16, so that's our mass number. The atomic number of oxygen is 8. And so there's our notation for oxygen-16. Oxygen-18 is another stable isotope. Again, we write the symbol for the element, and we write our mass number. Remember that you won't always see the atomic number. You may see it written just like this, because we can simply look up the atomic number on the periodic table. Maybe we have the isotope chlorine 35. The symbol for chlorine is Cl, mass number 35. We look on the periodic table and we see that our atomic number is 17. For a final example, let's look at the isotope uranium-238. Our symbol for uranium is U. Mass number we've identified is 238. And we see that our atomic number from the periodic table is 92. And so, to recap, we have 3 main subatomic particles in an atom. We have protons with a positive charge, neutrons without a charge. Both of those particles can be found in the nucleus of an atom. And then we have electrons with a negative charge found outside the nucleus of an atom. 2 main vocabulary terms. We have an atomic number, which we denote with a Z, and is equal to the number of protons in a nucleus. The atomic number is what identifies an atom. We also have mass number, denoted with an A, equal to the number of protons plus the number of neutrons in the nucleus. And then we have our basic elemental notation. Element X, with the mass number A, written as a superscript to the left, and the atomic number Z, written as a subscript to the left.